hypothesis. If copper metal is reacted with silver nitrate, then a single replacement reaction will occur and produce silver metal and copper nitrate.
An investigation was undertaken to determine and witness the effects of a single replacement reaction between copper and silver nitrate. Copper wire was submerged in 0.1 molar silver nitrate to produce silver metal and copper nitrate. The silver formed was dried, weighed, and analyzed to determine amount formed. The amount of copper reacted and lost was also calculated. In a single replacement reaction, one element is replaced by another in a compound. Typically, a cation and an anion in an ionic compound will disengage, with one of the ions attaching to the other one. A cation will attach to an anion and vice versa. In this case, the silver cation and nitrate anion separated, and the nitrate anion attached to the other cation in the reaction, copper, becoming copper nitrate. Thus, the silver became silver metal.
Materials: 1 6-inch copper wire, 10 milliliters of 0.1 molar silver nitrate, 1 250 milliliter beaker, 1 600 milliliter beaker, 1 electronic scale, 1 glass test tube, 1 sheet of parafilm, 1 pipette, 1 stirring rod, 2 pieces of labeling tape, 1 distilled water wash bottle, and acetone. Procedures: Day 1. Get a piece of copper wire along with a clean, dry test tube. Write the period and table number on labeling tape and apply it to test tube. Apply labeling tape with the period and table number to the 250 milliliter beaker. Find the separate and combined mass of the copper wire and label 250 milliliter beaker. Measurements should be to the nearest 0.01 grams. Record these masses in the lab notebook. Form a coil shape by wrapping the copper wire around a pen or pencil. Just as demonstrated, stretch the coil and insert into the test tube. Being extremely cautious, pour 10 milliliters of 0.1 molar silver nitrate into the test tube. Make sure to fully submerge the wire in the solution. Note observations of the reaction for 30 minutes. Place parafilm over the test tube and allow the reaction to continue for a span of 24 hours.
Day 2. Get one 600 ml beaker per table. Use this as a waste container. Use a stirring rod to shake the silver crystals off the copper wire. Take the copper wire out from inside the test tube and use the wash bottle to rinse off the wire into the labeled 250 ml beaker. Set the copper wire to dry once dipped in acetone. Find the mass to the nearest 0.01 gram of dried copper wire. Then place in your instructor's designated area. Use the pipette to cautiously decant the solution from the silver crystals back into the original beaker. Stir gently with rod after you rinse the silver with about 10 ml of distilled water. Leave the silver to settle, then decant into the other beaker. Continue for 3 more times. Discard the liquid from the waste beaker into the designated waste bucket. After you rinse once more, give your 250 ml to your instructor to place in the drying oven. Clean and dry the waste beaker. Day 3. Find the mass of the dried silver to the nearest 0.01 gram.
The mass of the Cu wire before the reaction was 1.13 grams. The mass of the empty labeled 250 ml beaker was 128.25 grams. The mass of the beaker plus Cu wire was 129.38 grams. The mass of the wire after the reaction was 1.09 grams. The mass of the beaker with dry silver crystals was 38.27 grams. The mass of silver crystals was 0.08 grams. The mass of Cu wire reacted was 0.04 grams. The mass of Cu reacted was 6 times 10 to the negative 4 moles of Cu. The mass of Ag formed was 0.08 grams of Ag. The moles of Ag formed was 7 times 10 to the negative 4. The expected ratio of moles to Ag of moles to Cu was 2 moles of Ag to 1 mole of Cu. The experimental ratio of moles of Ag to moles of Cu was 1.9 moles of Ag to 1 mole of Cu. The number of Ag atoms were 4 times 10 to the 20, and the number of Cu atoms was 4 times 10 to the 20. The experimental ratio of atoms of Ag to atoms of Cu was 1.1 times 10 to the 24 atoms of Ag to 6.022 times 10 to the 23 atoms of Cu. The percent yield of Ag was 58.9%, and the percent error of Ag was 41.2%.
Conclusion. During this investigation of the reactions between copper and silver nitrate, it was discovered that when a copper wire is submerged into a 0.10 molar solution of silver nitrate, it produces silver metal and copper nitrate. The copper wire quickly turned to a greenish color and grew thicker as time went on. After about 10 minutes of being submerged in the solution, the crystals started to develop along the copper wire. More crystals formed around the copper wire as time went on. 24 hours later, the crystals were ready to be removed from the wire. After removing the crystals from the copper wire, rinsing and drying the crystals, the weight of the crystals were measured. The mass of the crystals, once done with this process, was 0.08 grams. During this reaction, some human errors had occurred, such as not completely washing the glassware and eliminating all possible minerals that could have had an effect on this investigation. Also, rinsing the crystals too much that it became hard to withdraw the excess liquid from the crystals. There was a 41.2% error. The results of the lab supported the hypothesis. It can be determined that the aqueous product of the reaction had a blue tint, indicating the presence of copper.